Students, welcome to the subject Software Engineering. Today we are going to study behavioral model. In this category, we will be studying state machine model. The state machine model, point number 1, it's a type of behavioral model. We have students who have studied earlier another type of behavior model, that is data flow model. And now we will be studying state machine model. Point number 2. A state machine model describes how a system responds to internal or external events. Students, we have studied earlier that data flow model states how the data is processed, whereas state machine model describes how the system responds to the internal or external event. Point number 3. It shows system states and events that cause system transition from one state to another. So students, it shows the different states and events which are responsible for system transition from one state to another. It does not show the flow of data within the system. So, state machine model. Point number 1. This type of model is often used for modeling real-time systems because these systems are driven by stimuli from systems environment. So students, state machine model are most useful for real-time systems, as in real-time systems we have to take care of events as they occur and the system should respond accordingly. Point number 2. State machine model of a system assumes that at any time a system is in one of a number of possible states. So students, you know very well there are number of changes taking place in a system. So system moves from one state to another state. Point number 3. When a stimulus is received, it may trigger a transition to a different state. For example, a system controlling a valve may move from the state valve open to the state valve closed when the operator command is received. So students, we know system will change the state. For example, if you take help of a pipeline, the state can be valve open and another state can be valve closed. Now we are taking example of microwave oven model. Just see, look into this picture. You can see a state machine model for a simple microwave oven. We have got here, rounded rectangles which tells us the state, and there are different states shown by different rectangles. These rectangles these are named rectangles, and these rounded rectangles are connected by arrows which show the transition from one state to another. If you go in detail of this diagram, you can say that there is a state called as waiting. On the very left side, on the very top you have got full power. On the very bottom you have got half power. Then in the middle you have got set time. In that bottom you have got disable state, then enable state, operation state and waiting state. So a oven may start with half power or full power. And it will display the time. If you choose the full power, then you have to set the power to 600, and if you choose the half power, you have to set it to 300. So when you set the timer, okay, if the door is open, the oven is disabled, okay, and once the door is closed, the oven is enabled. Once the oven is enabled, it will start the operation, and once the operations are, if the door is open, again it will be disabled, and if the operations are cancelled, then it will go into the waiting state, and if the operations are over, then the cooking takes place. So state machine model of a simple microwave oven. The diagram shows the state machine model of a simple microwave oven equipped with buttons such as one power, next timer, and third the start the system. Okay, so there are 3 buttons which can be set to power, the timer, and to start the system. Point number 2. Sequence of actions in using microwave is select the power level. So you can choose the power level such as half or full. Second, input the cooking time. So you can set the cooking time as per your wish. Press the start and food is cooked for the given time. Point number 3. For safety reasons, the oven should not operate when the door is open, and on completion of the cooking, a buzzer is sounded. So we have seen this in the earlier diagram. Now we are using UML notation for the state machine model. Okay, I have described you earlier the UML notations. Okay, so the UML notations such as rounded rectangle and label arrows are seen in the diagram. Okay, these UML notations are used, okay, to describe state machine model and behavior of the objects. The rounded rectangles represent system state. They include a brief description, okay, such as in the bracket following the do operation of the action taken in that state. So in the rounded rectangle, you find that it is a named rectangle, and after command do, you find what is the action taken. The labeled arrows represent stimuli that force transition from one state to another. This we have seen in the diagram. Simple microwave oven diagram. The system responds initially to either the full power or half power button. Okay, we are describing the diagram. The time is set, and if the door is closed, the start button is enabled. Students, we are describing the diagram of simple microwave oven. 3. Pushing the start button starts the oven operation, and cooking takes place for the specified time. All this you can visualize in the diagram. Point number 4. The UML notation indicate the activity that takes place in a state. Okay, so these are described in the diagram. You can look at it. 5. The state and the stimulus description for a microwave oven can be provided as given in the next figure. So we got next diagram which will give us all the details. So microwave oven state description is available here. The states towards left and description towards right. You have got states such as waiting, half power, full power, set time, disabled, enabled, operations. So all these states you can study, okay, and I have described you all these states earlier. You can study them later for your sake. So these states will be available in PDF file also. Also you can see here stimulus and the description. Okay, you have got stimulus such as half power, full power, timer, number, door open, door close, start and cancel, and their descriptions are available here. Half power, the user has pressed the half power button. Stimulus full power, the user has pressed the full power button. So all this you can go through, okay, yourself, and it is available also in PDF file. I already explained all this. There are certain problems with this state machine model, okay. So in this model, the number of possible states increase rapidly. So when you are explaining the diagram with a state machine model, the number of states may increase rapidly. Point number 2. Therefore, for large systems models, some structuring of this state model is necessary. So students, when the number of states increase rapidly, you have to go for one more approach where you have to adopt some structuring for this state model. Point number 3. This can be done by using a notation of a superstate that encapsulates a number of separate states. The superstate looks like a single state on the high level model, but is then expanded in more detail on a separate diagram. So students, when there are a number of states, okay, then you can go in for different structuring. You can use the notation for a superstate. This superstate will be containing number of separate states, and these separate states, okay, are called as substates. In the main diagram, you will have single superstate, okay, and when you go in for expanded diagram or a separate diagram, it will describe what this superstate will do. So it will describe all the substates. This can be seen in the diagram in the next slide. So concept of superstate and substate. The concept of superstate and substates can be illustrated. So we'll check the figure in the next slide. Let us consider the operation state. So in the main microwave oven, we have seen there is an operation called as, okay, or there is a diagram named as operation towards very right. You can check in the middle. Okay. The superstate can be expanded as given in the figure. So we'll be expanding the superstate called operation in the next slide. You can just check it. So we have expanded in this diagram the operation which is named as, okay, is one of the superstate diagram. So it is expanded here in the substates such as checking, alarm, cook, done, okay, and also disabled and waiting states. Okay, so you can just check how this superstate is expanded into the substates. So the operation is expanded into various substates. Superstate and substate for a microwave oven case. The operation state includes number of substates. Okay, so this operation, which is we call it superstate, is expanded into number of substates, which you can see in the diagram. All this I'll be adding to the PDF file. You can write down from there. Point number 2. It shows that operation starts with a status check, and that if there is any problem are discovered, an alarm is indicated and the operation is disabled. Okay, so the operation starts with the status check, and if there is a problem, then alarm is indicated and the operation is disabled. Point number 3. Cooking involves running the microwave generator for specified time, and on completion a buzzer is sounded. All this you can, okay, see in the figure. So students, today we have studied, okay, the one more behavioral model called as state machine model. This state machine model, as we have studied earlier, are useful for real-time systems, and here the system changes the states from one state to another on some event, and these events are caused by stimuli. So please go through this PPT and then followed by PDF notes, write down them properly. Okay, and if there is anything, you can just give me a call. We'll stop here. Thank you.